This video is about stoichiometry and using mole-mole ratios. So first we're going to do a warm-up and something we've done before, which is converting back and forth between grams and moles and grams, because these are important steps in stoichiometry. And when you're going from grams to moles, you divide by the molar mass, which is the grams per mole, grams on the bottom, because it has to cancel. So divide by molar mass. And going from moles to grams, multiply by the number of grams per mole, which is the molar mass. So to practice, on this page, go through and write the formulas and do the conversions and then check your work. So don't forget that the first step is always going to be to correctly write the formula and then calculate its molar mass and then do the conversions. Grams divided by molar mass, convert to moles. Formula for magnesium iodide, molar mass, from moles back to grams, multiplying by the molar mass. So check your work after you've done these. And for sig figs, don't forget that you've got 3 sig figs in the starting number. So your final answer is going to have three sig figs. So mole-to-mole calculations, where we use a balanced equation and go convert from one reactant or one formula to another, using the coefficients, which represent the mole ratios of all of the reactants and the products. And coefficients are the numbers out front. So if there's no number, then it's a 1, the 6, the 3, and the 2. Those are the coefficients or the mole ratios. And what this means is for every 1 aluminum oxide, we are going to make 3 waters. And for every 6 nitric acids, we're going to make 3 waters or 2 aluminum nitrates. So we use it as a conversion factor, just like we would any other conversion factor. So starting with 3.6 moles of aluminum oxide, this is our given because it's what we have all the numbers for. And what we want to find is the moles of aluminum nitrate. So it can be useful to label the given, which is where you're going to start, and what you want or what you're looking for, because when things get more complicated, this can be very handy. So starting with 3.6 moles, aluminum oxide has to go on the bottom because it has to cancel. Aluminum nitrate goes on the top, moles of aluminum nitrate. The 2 and the 1 are the numbers out front, the coefficients. The 1 here and the 2 here. And then set it all up and then do the multiplication. 7.2 moles of aluminum nitrate are going to be formed from 3.6 moles of aluminum oxide. So go through and do the next couple and then turn it back on and check your work. Okay, so again, for each one, label the given and what you want or what you're looking for. Don't forget that what you're given can be the product. So in this case, water is the given, even though it's a product in the reaction, so it doesn't have to be a reactant. And what we're looking for is nitric acid, which is a reactant. So given just means we have enough information to start with that formula.